Hello and welcome to another Mr. Watson YouTube video. If you'd like to see me go through another topic, then please comment down below. Also remember to check the video description for any additional information. Welcome to the first video on Pythagoras' theorem. In this video I'm going to be demonstrating how to use Pythagoras' theorem with some example questions. So let's get straight into it. Pythagoras' theorem is used to calculate the length of a right angle triangle, and that's quite an important point, that it will only work out the length of a right angle triangle. You can use it as a very rough approximate with something that's not right angled, but the further away it is from being a right angle triangle, the less accurate it becomes. So sometimes, if you're just trying to work something out, what we call a back of the envelope calculation, just very rough workings, maybe you don't have a calculator, Pythagoras' theorem will sometimes do the trick, even when it's not 90 degrees, but it would have to be close. So Pythagoras' theorem is used to work out a length of a right angle triangle. In the future I will demonstrate how to work out the lengths of triangles where that they don't include a right angle. But in this video, right angle triangle only. So let's take this triangle here. If these two sides have these lengths 3 and 4, what would side x be? How do we work that out? Well, Pythagoras' theorem states that a squared plus b squared is equal to c squared, where these two sides here are the shorter lengths, and this side here is the longest. Now this has a special name. This is called the hypotenuse. It's just a fancy word for the longest length. So in this case here, we would have the two shortest lengths squared. So that would be 9 plus 16, which is 25. And that there is c squared. So 25 is c squared, the longest side squared. In this case, we don't have c, we have x. So that would be x squared. So to calculate there what x is, we need to square root both sides. So square root the x squared, we get x. Square root the 25, we get the square root of 25, which is 5. Now normally there I would say it's plus or minus 5, because the square root of 25 is plus or minus 5, but you can't have a negative length in the real world, so that there would be 5. Okay, well maybe you have this length here and this length here, so obviously you can see there from the first example this last length here will be 3, but how do we know? Well, if a squared plus b squared equals c squared, if the two shorter lengths squared added together is the longest length, then one of those shorter lengths will be the longest length squared, subtract the other shorter length squared. So a squared is c squared minus b squared. So here you would call that length a, that could be b, and that would be c. So here a squared, which is what we want, in this case it's y squared, will be c squared, which is 5 squared, minus b squared, which is 4 squared. So that is 25 minus 16, which is 9. So y squared is equal to 9, or y is the root of 9, which is 3. Again, plus or minus 3, but you can only have a positive length. Well, what if we have a triangle that doesn't have such nice lengths? We call this is a special triangle, the way the lengths are 3, 4 and 5. We call this a Pythagorean triple, or sometimes called a Pythagorean triplet. We don't always have nice lengths like that. So if we had this length here was 5 and this length here was say 9, what would this length be then? What would a be then? Or I won't use a actually, because a is used in these other things. Let's call that t. So here, this is one of the short lengths, that's the other short length, and that's the hypotenuse, the longest length. So here we would do a squared plus b squared equals c squared. So So that is 5 squared plus 9 squared equals t squared. So that's 25 plus 81 equals t squared. So what do these add up to give? They're 106. Now if you didn't have a calculator here, you would say that t is approximately, you know, 10.1, 10.2, 10.3, that kind of range. You know, I'm just going to guess there 10.3. But if you do have a calculator, then you can actually say, okay, well, t is equal to the square root of 106. And that's why I've got my calculator here. So if we do the square root of 106, press equals, so 10.295. So to, I suppose, to 1 decimal place, that was you know, that was a good example. Or to 2 decimal places, it would be 10.30. That's yeah, that's one of the best guesses I've ever had, I think. So you know, let's have a go at another question. Say if we have a triangle where this length is 7, this length is 16, and you know, we want to work out what that length is there. So in this case, we label it again. 2 short lengths are A and B. Doesn't matter which way around you put those, and the longest length is C. So a squared plus b squared equals c squared. A squared is 7 squared plus b squared, which would be in this case y squared, equals 16 squared. Okay, well, what does all of this, you know, what does all of this equal then? Well, that there would be 49 plus y squared. 16 squared. Well, what is 16 squared? 16 squared is 256, if I'm not mistaken. If you're wondering how I got this, I know that 15 squared is 225. So 16 squared is, of course, you know, 16 squared is of course going to be larger than 225. I also know that 16 squared is a power of 2. 16 squared is 2 to the power 4 squared, which is 2 to the power 8. So I know it's a power of 8, and I know that 2 to the power 8 is 256. So yeah, that's how I got that. So now we need to subtract 49 off both sides. So y squared is 256 subtract 49. So y squared is equal to 207. Okay, well here, same thing, you know, if you didn't have a calculator there, you would say that y is approximately the square root of that. Well, you know, the square root of that, it's not too far off 15, maybe it's, I don't know, 14.6, 14.7, something like that. So, you know, if you had to take a guess, not a bad guess to make, but let's work this out properly. Let's say that y is the square root of 207. So let's work that out. So the square root of 207, which is 14.3, I'll just say 14.4 to 1 decimal place. So yeah, so there we go. So I was a little bit off, but you know, not too bad of a guess. So yeah, so this here is Pythagoras' theorem. You start off with this equation here. You label your triangle. Always label your longest side as C. Always label the hypotenuse as C. Label the other 2 sides A and B. Doesn't matter which way around they go. And then you need to put all of the numbers that you're given into the equation, like we did here. We said that A was 7 squared. Well, A was 7, so A squared is 7 squared. B was Y, so that will be B squared will be Y squared, and then C squared is 16 squared. So you sub in your numbers, work out any of these square terms, rearrange to get just the letter, the unknown, on its own, and then take the square root. And there we go. So yeah, so in the next video, I think I'll just show some more examples of this. Now I've not actually given you any examples in this video. This is just me, kind of doing a bit of a refresher, or even just teaching you, what this is. In the next video that we look on Pythagoras' theorem, I'll actually give you some examples to do so that you can follow along. Yeah, that's everything for now. So thank you very much for watching.